Can everyone see this okay?
Perfect.
All right. Then we're going to move over to Thomas from AMG and LIVA to give an update on their new hybrid energy storage system.
Thanks, John, and thanks, Vanitech, for organizing this event. So I will give you a brief update on our activities on our hybrid energy storage systems. As you can see on this first picture, this is a combined activity of the entire AMG group, actually. There's many sister companies of LIVA that are involved in this project. Mainly, I'd like to mention GFE, so AMG Titanium Alloys and Coatings, and AMG Vanadium. Next, please. So I would like to start off with a small introduction why we are actually using hybrid energy storage systems. For us, hybrid energy storage system means this is, first of all, an intelligent software that is combining a lithium-ion battery and a vanadium flow battery. Why are we doing this? We actually want to increase the range of industrial applications by combining the advantages of different storage systems. So we all know the advantages of flow batteries, the high cycle stability and lifetime, the low energy cost, and the high safety and reliability. But there are other advantages, which are actually disadvantages of flow batteries, other advantages of lithium-ion batteries that are low cost of power, and a larger spectrum of applications, mainly due to the speed of the batteries. And by combining these two battery types with our software, we think we can increase the overall KPIs of these battery systems. This means higher lifetime. We're talking up to 20 or 30 years, as we have seen just in the talk before. High availability of the system and high safety. So we are targeting availability of more than 99.9%. And most importantly, we believe we can reduce the overall or the total levelized cost of storage of the entire system. So we believe we bring down the capital expenditure and the operational cost for the entire system. And we are doing all this to achieve a lowest possible CO2 footprint over the lifetime of our storage systems. I will say a few more words about that in my last slide. So now I'm showing two examples of installations. The first one is hybrid storage system that we have installed, and it is operational since Q4 21. It's installed at one of our facilities in Germany. On the left-hand side, you see actually a rather small lithium-ion battery in the container, and on the right-hand side, the flow battery. The entire system has energy storage capacity of 3.45 megawatt hours and the power of 1.1 megawatt. This installation has one main aim at the moment. It's peak shaving. So the installation was installed for this one purpose. And at the moment, we are reducing the grid costs. So this is something very specific in Germany. We are reducing grid cost by up to 80%. In addition, this installation has an emergency power supply function. Again, an advantage that is possible through the combination of lithium-ion and flow battery. So the whole system has a black start capability. Next year, in 2024, we are upgrading this installation. We are adding a fairly large solar installation on the rooftops of these neighboring buildings. And then we will increase the energy content by simply adding electrolyte into the tanks. In addition, we want to then provide grid services to the net supplier. The next example shows an installation that we are installing at the moment, again in Germany. And you see here again, we are building our facilities in buildings that can be existing buildings or buildings that are specially designed for our storage systems. We are not targeting containerized systems. So this system is a fairly complex system because it combines many different energy assets. So the intelligent software controls not only the battery, but it controls as well the entire energy production. So there is a large solar plant. There will be several wind turbines producing energy. There is a geothermal energy installation, and there will be a power to heat installation and a large charging facility for many electric vehicles on the site. So the whole, it's an industrial production site that is running 24/7. This production site would like to achieve a self-sufficiency of more than 80%. We put down here 70%. We are very convinced we can reach that easily, which is actually quite spectacular in a producing environment. So this installation has got the capacity of 4.2 megawatt hours with a power of 1.4 megawatts. So we are currently installing this installation. The building is existing already, and it should be operational in the first half next year. Next slide, please. So here I would like to show the value chain, because we believe it's very important to be not only a battery supplier or a supplier of an energy storage system, but to be a supplier of a whole system, including the energy management, and to be as much integrated, even going down the raw material road to the electrolyte. And this is what we are actually doing within the AMG group. So the heart of our energy storage systems is actually a software system that is the key component of our LIVA systems. But we are providing as well the full engineering activities, so the full EPC contracting with our sister company ALD in Hanau, Frankfurt. And we produce then, as you all know, via our sister company GFE in Nuremberg, the electrolyte to be able to provide the full system. In addition, we are not only installing the systems, we are maintaining them, and we can even provide energy as a service or power management as a service. What we have not integrated yet is lithium-ion batteries that we are buying, and some power electronics. And I will conclude my talk with the final slide. It's on our green mining strategy. So as you might know, AMG is not mining vanadium in the classical way. We are recovering vanadium from the petrochemical industry, from the oil and gas refineries. So this vanadium is then recovered in our installations at AMG Vanadium. We are actually having a joint venture as well with some petrochemical companies. The vanadium pentoxide is then transformed to vanadium electrolyte at our sister company GFE, which then supplies LIVA with the electrolyte for our flow batteries. And this is then a closed system, so we are convinced this this production route for the electrolyte has a much lower CO2 footprint than classical way of mining. And this concludes my talk. Thank you very much. John, you're on mute.
There we go. Thank you, Thomas. And again, if anyone has any questions, please put those in the